it has mass, a measurable mass, right? Which will be given as 0.1 gram. So it has a mass. If you suspend it there in the free space, then we're expecting it to have weight, which is mg, right? And the mg always is perpendicularly acting downward of the body. What does it mean? For instance, suppose that this is the charge, right? So this is the ball 2. So there is a weight that acting perpendicularly downward to build the center of the gravity, right? So that's what we call it mg. So if we have mg, but again we say that here we have something called the tension of the string, and also here we have tension of the thread. Say tension of the thread. So this again is a right angle, it's a equilateral triangle. In case that I drew it badly, you have drawn it. I think that I drew it badly. Yes, the way it is, I drew it badly. So you can even change. You can even change. So there's no problem. You can even change. You can draw yours neatly. Okay. So this is, let's say, here we have ball 2. So this is ball 2. At least there. Yeah. So listen, so this is right angle triangle. See? So suppose that this we call it A, B, C, D. So now we have a right angle triangle which is called A, B, D. Listen carefully. So because this line is dividing, so this is 30 degree and here we have 30 degree. Right? Listen carefully. So what does it what is going on? Again, another, so here we have the first force is the weight of the ball. The second force is the tension of the thread. Okay? The tension of what? Of the thread. But this tension of the thread is diagonal. It means that it's acting at an angle. It's not perpendicular like this one. Right? It's acting at an angle. So this tension has two components. It has horizontal component and vertical component. Right? So the vertical component of the thread will be acting perpendicular to balancing weight, right? So this we call it vertical component. So vertical components of the tension, right? So vertical components of what? Of the tension. Again, if we consider this ball 1, we have horizontal components of the tension of the thread horizontally, right? So we have horizontal, because this is directing this way, so even this horizontal, so we'll be acting here. So we have horizontal, component of tension. Are we together? So how many forces we have now? First force, second force, third force. Right? But again, what are these charges? These are like charge. According to the fundamental law of electrostatic, like charge, repel. Right? So if you repel, it means Q1, for instance, if this Q1 is pushing what? Q2 away. That is push force. And also Q2, for example, if this is Q2, is pushing what? Q1 away. Like this. Are we together? So again, so in ball 2, we have again another component of force, which is, we call it force of repulsion, which is electrostatic force of repulsion, which determines by using the Coulomb's law. We together. Physics is beautiful and very interesting. And if it reaches to that point, now you find that why few students are the only one who manage to study and understand physics. Because it really needs your mind to be useful. Are we together? So well. So if that's the case, before even if just we resolve, we say that, I want just to summarize. So you say that the forces, say forces. So forces on what? On ball 1. Right? On ball 1. So you have 3 forces. The first force is what? Weight, which is mg. The second force is what? Then you say vertical component of the tension. So you can say that, for example, that there we call that vertical component of the tension, or you can call it that vertical TV. So vertical components of the tension. Right? And then another one, another force, we have what? Horizontal component of the tension. And this is equal to, you can call it horizontal components of the tension of the thread. Right? Okay, so my students here are doing some other business arts from the class. So Roman 4, again number 4, we have again another force, which is called the force of repulsion. Right? So you have 4 components of what? Of force. So we say that before even we come back onto the second sentence, that themselves, they are at equilibrium as shown below. So we'll come to that point. Okay? Okay? So they come, mean that before we come to this point, we want to deal with something else. And that one is what? Is the second step. The second step. So the second step, we say that let us resolve what? So it's resolving all the forces. So let us resolve the forces. Resolve what? Forces. So to resolve forces, resolve all the 4 forces. Because you know now there are 4. So resolve all the 4 forces. So this first step, you can say that, okay, resolve all the forces that act on the ball diagrammatically. So by using diagrammatical. So by using what? The diagram. Now I want to resolve forces by using the right angle triangle, right? Right angle triangle, which is AB or ADB or BDA. Right? Okay. So to resolve the forces, listen careful. We know the weight mg, we know the force of electrostatic, but what do we need? We want to know the horizontal components of the tensions and vertical components of the tension, right? So we are interested with 2 forces. The first one are horizontal components of the tension, TH, let's say, right? So how do we do it? So this is the right angle triangle, ADB or BDA, right? So we have the angle which is 60. So we say that we'll put that angle later. So, but in order to get this horizontal component, we have to use what? Cosine angle, cosine of this triangle. So cosine said that adjacent over hypotenuse, right? So you say that to get this component, we say that cosine of n angle theta is equal to what? Adjacent of the right angle triangle of what? Hypotenuse. So cosine of angle theta, which is called theta, adjacent is equal to what? Adjacent is equal to horizontal components of the force, right? Of what? Hypotenuse, which is tension, right? So we say that the horizontal components of the tension is equal to tension times cosine of angle theta. Are we together? Okay, so this is, let's say it is our first equation, right? So the second components of force that we need to know is vertical components of the tension. So vertical components of the tension say that sine of angle theta. This is equal to what? This is equal to opposite of the right angle triangle of what? Hypotenuse. Right? So what the opposite of this angle is this one. And this is vertical components. Right? That's going up. So well, so we say that what? So we say that, okay. So we say sine of angle theta for any triangle. This is for any, and these are the procedures that you have to follow to solve any type of the questions. So this is sine. And remember that I told you there's a homework that the students has to do by following these procedures. So listen careful and follow along. Tan theta, what the opposite there? The opposite side is what? Vertical components of tension. Then the hypotenuse is what? It is tension. Well, so make tension, vertical components of the tension, the subject. So this is T sin what? Theta. So this is the second what? Equation. Okay, so you have those components of force. What happens? So then we come back. Themselves, those two charges that are those two charges carried by the 2 identical balls, themselves, they are at equilibrium. What does it mean? These are the 4 forces acting in different direction. This is acting in this direction. This electrostatic force acts in this direction. The weight is acting downwards. The vertical components of tension acting upward. So if these forces, all the forces are at equilibrium, it means that the electrostatic force is equal to the horizontal components of the tension. And also the weight of the ball is equal to the vertical components of the tension. And the physics is beautiful. Right? So that is step number what? The steady state. So the steady state, we say that at equilibrium, right? At equilibrium, number 1, what are we going to experience? The electrostatic force of repulsion. This will balance with horizontal components of tension. The horizontal components of the tension, we say it's equal to the tension cosine of angle theta. Well, so this will make what? Equation 3. Just for the purpose of labeling. Then the second system which is at equilibrium, we say that the vertical component, which is TV, this is going to balance with weight, which is mg. But this vertical component is equal to tension times sine of angle theta. So this is what? Equation 4. Are we together? So you see now how mechanics is important. Yeah. So we have those two equations. So then we have to think mathematically now. We have to think in terms of physics. How we can use them to solve the problem. Well, the way that we can use them to solve the problems, we got the forces tape. The forces tape now, we say fine. Aha. Oh, okay, fine. So the forces tape now, or we can just simplify them, write them in a simplified form. So we say that the electrostatic force of attraction, this is equal to tension cosine of angle theta, and this we call it equation what? 3. And then here we have what? The weight mg, this is equal to what? Tension sine of angle theta. Okay, so if you have realized this something that of the trigonometrical concepts, so we can relate this sine and cosine. How we can relate? We have to think and remember the trigonometric concept that if we take sine over cosine, we get another trigonometrical phenomenon that's called what? Tangent. Wow. Aha. So you simplify this sine and cos, and the tensions will cancel. You see? Tension and tension will cancel. So if you cancel, we'll have mg over f is equal to the tan theta. And theta is known. Right? So let me clean here. In case you find that I'm teaching you quickly, don't worry, the video is there for you. You can watch the video several times as well as you can. So we go for the forces tape, right? The forces tape, we say that now we have to take equation what? Equation 4, we divide with what? Equation 3. Equation 4, the left hand side is said what? mg, and then equation 3, the left hand side is said what? Force. Then this is equal to what? mg is equal to what? Tension times what? Sine of angle theta. Divided by what? Tension, or there is cosine of angle theta. Right? Tension and tension cancel. Good. Sine over cosine is equal to the tangent of angle theta. Excellent. Beautiful. So now, aha. Remember what are we looking for? Quantity of charge. Well, so then we say that we have our new expressions, mg over force is equal to tangent of angle theta. We don't have any tensions anymore, but this expression can help us to, what does it help us? This equation helps us to get the electrostatic force of repulsion. 1. We know the mass of the ball, it is 0.1. Again, we know the gravity, it is what? Constant, 9.8 meters per second squared. And then we know the angle. The angle is what? Is given, 60 degrees. Then we get the electrostatic force of what? Repulsion. So we go back to the what? To the Coulomb'S mathematical equation. Well, so it is the case now, we say that, okay, fine. So we go for the physics tape. The physics tape, now we say that make F the subject, of what? Of equation 5. Right? So make F the subject, so this is tan theta over 1. So we cross multiplication. Right? If you cross multiplication, what do we get? So you get that, for example, we can reciprocate. If just you get confusing, yes, if you cross multiplication, we get mg is equal times 1 is equal to force times what? Tan of angle theta. So make force the subject. So divide by tan theta, and then so divide by what? Tan theta. So what do you get? So you get electrostatic force F. This is equal to what? Weight mg over tangent of angle theta. Right? So if this is the case, we can compute, because I know many students, sometimes they are not good in physics. If they are good in physics, for me, I used to find a formula and then I'm going to plug another formula, and it becomes a little bit complex and later, now you can think a little bit different. Okay? Okay, so because it's a second example, I don't just let us compute. What the mass of the ball will be given 0.1 gram. So 0.1 gram, 0.1 gram, change it into kilograms. So exponent negative 3 kilogram. Then so you multiply by 9.8 what meter per second square divided by what tangent of angle theta, which is tangent of 60 degree. Use your scientific calculator. Give me the force. Give me the force. Give me the force. Give me the force. You student, give me the force. Give me the value of the force. Okay? Give me the value of force. So it's simple. You take your scientific calculator. You just ask it to help for you to make the computation like this way. So we take 0.1 exponent negative 3, then multiply by 9.8. You may use also 10. So in the if the questions will appear in exam, we'll be given the acceleration of gravity as a constant. So it's 9.8 exponent negative 4, and then we divide this one with what tangent of 60 degree. So the answer is what? So the electrostatic of repulsion between two identical balls that carries the identical charge is 5.658 exponent negative 4 Newton. Is it? Okay. So then now we have the force. But you have to go back to the questions, okay? The questions ask us what? We have to calculate what the charge on either ball. Okay. Physics is beautiful. So you go for the 6th step. Don't you worry. I'll be with you. I'll give you a compound. The 6th step, right? So the 6th step, we say that we have to recall what the Coulomb, or bestie, the Coulomb, right? The Coulomb mathematical formula, or the Coulomb formula of what? Of electrostatic. The Coulomb formula of electrostatic, how does it state? We say simply force of repulsion, for this case, is equal to K. Then we say that Q1 times Q2 divided by what? Relative permittivity, and then same sort the square of the distance, which is R. Well, the questions have been asked that these two balls getting identical charges. So Q1 is equal to Q2 is equal to Q. Well, again, because the mediums is not mentioned, you have to note this one. The relative permittivity of air is always equal to 1. Right? And if mediums is not mentioned, it means the mediums is free space. Unless there's been mentioned. If it's another medium, the question will state. Like the previous in example 1. So if that's the case, now we say that, okay, our electrostatic force is equal to K, then we have Q squared over what? Over square of the distance apart, which is 0.4. Right? You know the value of K? Yes. You know the value of R? Yes. You know the value of force? Yes, we computed. Can you find now Q? Yeah! You can find your value Q. And then you enjoy the beauty of physics. And then you say, God, thank you for sending me to Form 5 of advanced level and studying physics. Thank you, Father, for bringing physics into this world. Okay. So for this case, we have to make your Q the subject. So we say that make Q the subject. Okay, make Q the subject. So to make Q the subject, we say that if you make Q, because we did it in example 1. So it means finally we'll get that FR square of what over K. But this one will be the square root. So remember, I taught you the procedures of reaching that point, right? And then we have to do the computation. So square root of force. Force is equal to what? 5.65. And then what? 8 exponent negative 4, right? And then this square of the distance, which is 0.4 square. And then divided by what? K. What is K? It is 9 exponent 9. Right? So use your scientific calculator to do the computation. And so now I can clean the blackboard. So now you understand when I write a question, this concept, you know the business which is going to be around here. So let us use our scientific calculator. Let me give you a compound at the beginnings, later on, because for me I did my own computation. You'll be doing yourself, because I know some of you maybe have forgotten, so you don't know how to use your scientific calculator on the computations. Exponent negative 4, and then this is what? This is 0.4, and then square, okay, and then so divide by what? 9, exponent 9, then we find the square root, or square root, it's what? Square root of the answer, it is 1. Excuse me, I think that I pressed the calculator, the equal sign twice. So 5.68 exponent negative 4 multiplied by what? 0.4 square, okay, divided by what? 9 exponent 9, this one. And then we find the square root. It's 1.0048 exponent negative 7. So the quantity of charge carried by the two identical balls, suspended by the thread, is 1.00004 or 5, let's say, and then exponent negative 7 Coulomb, right? So this is a small value of Coulomb. So I told you that you have to express it in micro Coulomb, right? So it will be 0.05, and then you say what? Exponent negative what? 1 micro Coulomb. Why? Because just multiply this one with 1 exponent 6, right? So that is what? So that is Q. So it means you can say that Q now is equal to 0.1005 micro Coulomb. So if you estimate it, it means that the quantity of charge simply is equal to 0.1 micro Coulomb. So therefore, the quantity of charge, right? The quantity of charge is 0.1 micro Coulomb. Okay? So if that's the case now, I want also to remind you, we have one of the constant we call the electric permittivity of the free space. This is constant. I mentioned that it's 8.85 exponent negative 12. But also this constant, it has been given in your scientific calculator. For example, if your function R0, the function 991, right? Okay, 991, okay? So there's a back cover. So in back cover, you have to press constant button of the scientific calculator, and then you'll be looking the permittivity of free space, which is 32. Okay, 32. So you press the constant, this is the constant button, right? So you press it once, then you plug 32, and then permittivity of the free space appear on the display. Then you press the equal sign. Then you find is what? 8.854187817 exponent negative 12. The only thing that a scientific calculator won't give you, it will give you the value of the constant, it won't give you the what? The SI unit. But you know how to determine the SI unit of any physical quantity by using dimension. That's why we taught you in mechanics. Well, that's another additional concept. So now I want to take you on to example 3, which is the homework 4. You have to make sure to do this question before you join me in session 5. Because in session 5 also, I will teach you about superposition principle and how we can resolve forces now. And then in session 6, I will teach you problem solving of superposition principle and Coulomb'S law and fundamental laws. And even the session 6 or session 7, it will be problem solving. Possibly the session 9 is the problem solving until you master this stuff. Right? I have some of my students here who are really enjoying. So now we have example. Example 3. Example 3. Example 3. You have to enjoy physics. And this example 3, let me just warn you, it's the concept. For those who want to go quickly to the home, I said this is the homework, right? So this is homework 04. And you have to submit your solution in the comment section of this video that you're watching right now. And then the question stating that 2 balls, 2 small spheres, 2 small spheres, 2 small spheres, each having mass each having mass, okay, each having mass, okay, of what? Of 0.1 gram, okay, are suspended from a point, okay, from a point by threads, okay, threads of 40 of 20 centimeter long, 20 centimeter long, right? 20 centimeter long. They are equally charged. They are equally charged. And they repel. Equally charged and they repel. Equally charged and they repel each other to a distance, okay, to a distance of what? Of 24 centimeter. What is the charge? What is the charge? What is the charge on each sphere? On each sphere. What the charge on each sphere? That's your homework. Let me read clearly, because some other students say, oh, sir, you know, you have been writing quickly, so I didn't understand the homework. You have a long story because you don't want to work on yourself. Two small spheres, each having a mass of 0.1 gram, are suspended from a 20 by threads of 20 centimeter long. This is the length of the thread. They are equally charged, those two small spheres, and they repel each other. What does it indicate? Okay, I don't want to tell you because it's homework. To a distance of 24 centimeter. Fantastic. What is the charge on each sphere? So that's the homework. Very simple homework for those for those students who are senior, for the senior students. Right? But don't think it's easy. Do it on yourself. Go revise example 1, example 2 before you come and try. Revise several times. You got the video in there. You can revise several times until you understand the information. Then these questions will ask it. You have to respect me. I should not respect your question. You have to respect me because I know you. Alright? Okay, so let me take you to the last example for this session, which is example 4. So in session 5, I will be able now to teach about superposition principle of electrostatic. We have two superposition principles in physics. One is superposition principle in wave, and the other one is superposition principle in what? In physics. However, that the syllabus does not mention, but you will need it to solve questions even of electric field. Right? Because the syllabus is just indicating that you have to go to challenge, for instance, from Dar es Salaam. But it doesn't tell you that how you can take a route to challenge. It's your business. Okay, so we are in example 4. Example 4. Okay? Example 4. And this example 4, right, concept. And I don't say that concept because I want to lie to you. I want maybe to make you unhappy. I'm telling you the truth. Do it. You will see it. You will see that, here there is a hidden concept. Okay. The question said that, and this is, I took it in past paper because I told you that I'm using the past paper, one of the reference material that I told you in session 00, General Introduction to Physics, Advanced Physics for the Form 5 and 6. I took it from pre-NECTA, which means Pre-Advanced Certificate Secondary Education Examination, or we call it a pre-NECTA, right? Or 40, pre-NECTA of Zumbe, Okay? Zombe. High secondary school. So Zombe secondary school. So listen the question carefully. Two identical spheres. The aim of us teaching you many questions is we want even yourself to use this knowledge to think on how you can solve real life problems in your community. Because we are going to school to solve problems, to come back to our community and solve problems existing in our community first. But Sunday you can go to school and thinking that how can I solve the problem that is going to help the entire world. Yes, that is good mind. But I think that you have jumped some steps, some preliminary steps. Begin with your own community. Begin with the problems existing in your village. Begin with the problems existing in your street. Think, how can I solve this problem? Right? Don't be happy to be employed, to graduate with your certificate, and you are being employed, or you employ yourself, and then you enjoy that now I'm getting money, okay, so I can take care of my family, I can build a house, I buy a good car, okay, and then so what is the legacy are you going to leave? Everybody has a car. You know that now I'm paying the tuition fee for the kids. Yes, that is good. That's the parental issue. Every parent is doing that business. So what will be your unique contributions on this planet Earth before you leave? That's what I'm working for, and to help you to know, because there is a purpose for you to be in this world. Whether you know or you don't know, but God had a purpose to bring you. And there's a problem is waiting you to solve. Nobody who can solve it rather than you. So if you decide to go to the grave with the solutions of that problem, when we go to the throne of the judgment, we'll be asked that, you Olenjolai, my beloved son, I sent you to teach A-level students of the United Republic of Tanzania. Why didn't you teach them? Oh, you know, sir, God, they said, oh, sir, God, you know that I didn't have money. No. Were you born with money? No. Did you come to heaven with money? No. So why did you allow money to stuck you? Oh, you know, God, I'm come from a poor family, and even myself, that I was poor. Am I poor? No. So why did you compare me with your family? So then I'll present all the excuses, but finally he said that, my son, you wasted your time on the planet Earth. So that's what made me to be fearful to God whenever he gave me assignment, regardless of how difficult it is. One of the difficult level to teach is advanced level for the syllabus of United Republic of Tanzania. I tell you the truth. And that's why even many teachers are to quit it, because it demands you to study even more than the students that you are teaching. Okay, so how about you who is watching this video now? What problem are you going to solve? A unique problem. Nobody who will solve rather than you. And then will be blessed. Touch it to be, and then will be blessed. Will be blessed. Don't enjoy passing, having certificate, having job, and then for what? For what purpose? I'm not saying that having a job to be employed is not bad. That is good. I'm not saying that to employ yourself is bad. That is good. To get money to pay for your vision. My question is, what is your legacy in the planet Earth? What history are you going to write it when people will come to your area of interest? They have to refine. Okay, so as a student they say, sir, show us the way. Good. God is the way. And if God is the way, if you don't understand that sentence because you are not reading the word of the truth that's found in the Bible, but I can tell you that this is the one of the assignment, unique assignment that I have to do. So this is my unique assignment. So I'm doing my unique assignment that caused me to come into Tanzania. So this is my unique assignment. It's a hard, it's a difficult, but I enjoy it. I'm get happy when I teach. More than, it's just like you, that some of you used to go to the entertainment places. This is my entertainment for me. Wonderful. Some of the students, they say, no, sir, you are lying upon us. Okay? You are not my soul. I'm telling you the truth because I'm in the presence of God. So why should I lie to you? I don't know how to lie. That's how the story. So if you hate the truth, get prepared to hate me also. So let us come to the business. Two identical spheres. So it is still kind of the same phrase, yeah? Two identical spheres, but wait, you'll see how stuff are getting changed slowly. So this is the example 4. Tell your neighbor, this is the example 4. So it's not like example 1, which is straightforward, plugging the formula and make the subject. This you have to think. Okay, and you are very intelligent more than this question. That's what I want to tell you. But the issue is you haven't used the skills and the intelligence that God has given you for a long time. It has been in vacation. Why? Because you are striving to simplify life by training. Okay, so two identical spheres, those are the psychological. It's one of my responsibility that God has given. Two identical spheres, A and B, are situated some distance apart. So when you read the question, you have to imagine the real situation. And then each has positive Q, Coulomb. What is Coulomb? You forgot even the definition of Coulomb because stuff now are getting tough. But we define it. Okay? And they repel each other with the force of 10 × negative 5 Newton. So these are the likely charge. They repel each other. We'll be given sort of the force. But each of the charge which is called the positive Q. Those are the two identical spheres, A and B. Okay? The third uncharged sphere C is first attached to A. So I have 3 charges. I have 3 charges. For instance, I have 3 charges. So I have charge A here, and this is charge B. Right? So sphere, yes, this is sphere A, sphere B. The distance between the center part is not known. Distance known, right? Okay, so this is the distance that apart them. So this is positive Q and this is positive Q. Okay? So what happens there? So these positive charge repel each other. And then the distance apart them is Q. And they repel each other with the force of 10 × negative 5. Then you have a steady charge. The steady charge is the said uncharged sphere C. Is first touched to A, right? And then touched to B. Then will be placed midway. So it is charged here. So what's happening there? There's a distribution, means exchange of the charges. And then this charge, it is touched to charge B. So the exchange of charges also. And then this now sphere C has been placed there at the middle. Hey, that's the beauty of advanced physics now. Your head is paining now. I know that your head is paining, that what is this man is presenting. First of all, these are the questions from the books that I've mentioned. So I didn't design myself. So don't think that I'm complicating your life. Somebody has already complicated your life because he has composed that question. Okay? So for me, I'm simplifying your life. Because I'm going to solve this. I won't leave at the homework for you because you can quit even physics and you can quit even advancing labor. Okay? Without even saying goodbye. Okay, but you tell physics, I love you, but unfortunately you don't love me. So, okay, I have to agree. Okay, and then midway between A and what and B. Find resultant force on C. Interesting. Very interesting. The way it is interesting, first of all, when you read the question, you have few data more than the formula. We call this, with the physical quantity, you are going to find the formula. So when you write the formula, you find that you have few data and you have many unknowns with one equation. That's what happens because you have only force. And then you have now 3 charges that are B plus. You don't know the distance between them. Can you imagine? Then the question asks you, what is the resultant force? Can you think? Pause the video and then think about this question for a minute. How are you going to solve? Suppose that you found these questions in advanced certificate secondary examination, advanced secondary examination, okay, advanced certificate secondary education examination. You find it, whether it is 2023, or maybe 2022, or maybe 2021, or maybe 2026. What are you going to do? Will you leave that question? And remember that electrostatic is contributing a question in paper 2. So mostly you find that its question scale is 15 marks to 20 marks. Are you ready to leave those 15 to 20 marks? Are you ready? Are you really ready? Are you ready? For me, I won't agree to lose it. Because it means I have paid my tuition fee for nothing. You have to keep on fighting. Solution. So, two identical spheres A and B are situated some distance apart. So I'll be doing this question in chunks. So the first step before even, okay. So you see, for this question, if you even write that are given, it won't contribute anything else. But you have to begin on reminding that are given of all level, right? Because even myself, that's why I have been learning physics. So the first step, we say that you sketch the first part. Sketch the first part. Sketch the first part of the problem. Sketch the first part of the problem. How do we sketch? We have two spheres, right? And then this is another sphere. So we have a distance apart. This is A. This is B. Right? We have two spheres, A and what? A and B. Okay. Each has a quantity of charge of 40, Q. And this one is what? Q. But what? Positive Q, Coulomb, but Coulomb. And this positive Q also Coulomb. They are being separated by the distance apart. We don't know these distances are. Right? And then we say that, and they repel each other with the force of 40, 10 power negative 5. So this one is being pushed with the force that is 10 power negative 5 Newton. And this one also is pushed away with the force that 10 power negative 5 Newton. Right? Good. The said uncharged sphere now. So that is case 1. So this is what? Case what? Case 1. We go for case 2, which is the second step. So you break the question. I gave you a promise that I'm going to use different teaching aids and different teaching approach on teaching electrostatic. So I will be teaching you in different, I will simplify. These questions, it's look like very complex. Yes, it is true, it is very complex. But we'll be trying my level best to simplify it. So the second step now, we say that, wow. So you say that, we have again a sphere C. And the sphere, the third uncharged sphere uncharged. So this is charged, and this is charged. So you have a said uncharged sphere, right? Said uncharged sphere, and this is sphere C, but it's uncharged. So quantity of charge is 0, not remaining, right? So it has been touched to A. So if it is changed to A, this is uncharged sphere, but it can be charged. What's going to happen? It means the sphere A is going to charge sphere C. Fantastic. So it's a concept of charging, which we learned during the fundamental level. So sphere A is going to charge your sphere C, because we say that the third uncharged sphere, the third uncharged sphere C is firstly touched to A, and then touched to B. So firstly touched to A, so you have to do computations, what happens after touched to, it has been touched to A, that's number 1. And then this is second case, right? Which you are going to do. And then afterward, after it has been touched to A, so then it has been taken away, right? Now we have a new sphere C, which have a certain quantity of charge, which has been charged by sphere, what? A, which you have determined what the magnitude of that quantity of charge. Then now, we are touching this sphere C, right? We are touching this sphere C, which is sphere B. That is what? Case what? This is the third what? Third case. Ha ha ha. steady case. I like these questions because they really testing the understanding and the lovers of physics. The good thing that questions like this one is going to repel with those people who are not serious in physics. It's going to repel them, right? So this is the steady case, right? First case, second case, third case. And then the last case, then, that to be, the last case, then they will be placed midway. That the casioti, that is the first case. Tell your neighbor the first case. Ask your neighbor, do you really enjoy physics? Do you really enjoy physics day after day, or do you really get far from physics day after day? Because there are the two phenomena. But I want to give you a promise. If you'll be joining with me under the guidance of God, I'll be helping you to attract physics. You'll be attracted to physics. You'll be coming close to physics and tell physics, you are my friend, you are my friend, you're my friend. Okay. I should give you some kind of physics entertainment, yeah? Otherwise that you get discouraged with the life that is going on there after that. The first case. Okay. Now we have sphere A, and this sphere A, it has been changed because it has changed this sphere C, right? And then we have what sphere C somewhere there. This is sphere C. Also, the charge, the original charge, the new charge of sphere C is not the same like original because it has changed sphere A. This is sphere B. So the new charge of sphere B is not the same like the previous charge of Q, positive Q. Why? Because it has changed to sphere C. And then midway, so say midway. So midway, what does it about midway? So in between, so here we have a certain distance, and here there's a certain distance. This is sphere C. So what happens here? Here we have a distance we call it D1, and here we have a distance that we call it, let's say, D2. But because this is midway, D1 is equal to D2 is equal to D. That's very important keyword for your computation. So the distance between